Now separation of losses test. This test is used to find the hysteresis losses and eddy current losses of a transformer. And why this is called separation of losses test means total iron loss of a transformer is separated into hysteresis losses and eddy current losses. The circuit diagram for this test is similar to that of open circuit test. In open circuit test, HV side is left open and on LV side rated voltage is applied in open circuit test. But in separation of losses test, the source used is variable voltage, variable frequency source. To measure the input power, we are making use of LPF wattmeter, which are having terminals ML, C, V. And to measure the input voltage, MI type voltmeter. And to measure the input current, MI type ammeter. And here the source is variable voltage, variable frequency source. As it is discussed from the losses topic that hysteresis losses is directly proportional to frequency and eddy current losses is directly proportional to square of the frequency with V by F ratio constant. So this is the important point that you must make a note. Means in separation of losses test, V by F ratio is maintained constant. Therefore, now hysteresis losses you can write as WH is equal to A into F, where A is proportionality constant of hysteresis loss, and eddy current losses is taken as equal to B into F square, where B is proportionality constant of eddy current losses. That implies total iron loss is equal to hysteresis losses plus eddy current losses, which implies Wi is equal to A into F plus B into F square. Take F common from this and bring that to left hand side, which implies Wi by F is equal to A plus B into F. This is the important relation to know how to find the eddy current losses and hysteresis losses from iron losses. And if you observe this equation, this is similar to that of Y is equal to mx plus c. That is, this is Y and this is C, and F represents X and B represents M. Y is equal to mx plus c is a straight line equation. If constant c is 0, then y is equal to mx, and y is equal to mx is a straight line passing through the origin. And if y is equal to mx plus c, then it is a straight line like this. From here to here, it will represent c, and m is the slope of the line. Now let's relate this straight line equation with this equation. Y-axis is Wi by F and x-axis coordinate is F, and as this is y is equal to mx plus c, so the graph will be like this, and from the origin to this point it represents constant c, and from this the constant c is a, and b represents the slope of this line, and it is known that slope of the line is equal to y2 minus y1 by x2 minus x1, where y1, y2, x2, x1 are the x-axis and y-axis coordinates of any 2 points on the straight line. Which means if you find slope of this line, we will get b. Let us suppose this is x2, y2, and let us suppose this point be x1, y1. So b is equal to y2 minus y1 by x2 minus x1. In numerical problems, a graph will be given like this, and it will be asked to find the hysteresis losses and eddy current losses at a particular frequency, let us suppose at 25 Hz. Then by observing this graph, you must first find the constant A and constant B. So from origin to this point, it represents constant A, and here constant A is 20, and to find B, B is the slope of the line, and if you take any 2 points on the straight line, slope B is equal to y2 minus y1 by x2 minus x1. So here the x-axis and y-axis coordinates are 50 and 30, and on this point the x-axis coordinate and y-axis coordinate are 0 and 20. So B is equal to y2 minus y1 by x2 minus x1. So B is equal to 10 by 50, that is equal to 1 by 5, that is equal to 0.2. As it is asked to find the hysteresis losses at frequency 25 and eddy current losses at frequency 25, as we got A is equal to 20 and B is equal to 0.2, so place A here and frequency F is equal to 25, then obviously you will get hysteresis loss, and similarly place B in this and frequency is 25 square, so you will get eddy current losses, and therefore the total iron loss is equal to hysteresis losses plus eddy current losses. Now let's see the procedure to conduct this test. First, connect the circuit as shown in figure. Here our aim is to find A and B, by which you can find the hysteresis losses or eddy current losses at any frequency. Means we need to obtain this graph, and when you obtain this graph, from origin to this point represents A and the slope of the line is B. Therefore the second step is increase frequency and correspondingly make changes in applied voltage, because V by F ratio is to be maintained constant. If suppose the initial frequency be 50 Hz and input voltage be 200 volts, that implies V by F ratio is equal to 200 by 50, so which is equal to 4. Now by varying the frequency from variable voltage and variable frequency source, if 100 Hz is applied, then to maintain V by F ratio constant, the V need to be applied is 400 volts. As here in this test V by F ratio is to be maintained constant, so with increase in frequency we must make corresponding change in the input applied voltage. And the third step is note down voltmeter reading, ammeter reading and wattmeter reading. And from open circuit test it is studied that the wattmeter reading indicates the iron loss of the transformer, so we can take W0 is equal to Wi. And the fourth step is draw the graph and find AB. That is, for different values of frequency, note down the input voltage reading, ammeter reading and wattmeter reading. Here W0 is equal to Wi, so then find Wi by F. Now for different values of frequency, find Wi by F, and by using these two draw this graph, and after obtaining this graph, from here to here it represents A and slope of the line represents B, and from this graph for any frequency you can find the iron losses of that transformer. Thank you for watching. If you like this video, please like this video, share this video and do subscribe to this channel. Thank you. See you in next lecture.